Now we're going to look at molecular formula. The molecular formula is the actual formula for a molecule. It's what it is. So H2O is a molecular formula. It also can be the empirical formula. So the molecular formula is how that compound actually exists. Let's look at a problem here. Here's a problem. It says a compound has an empirical formula of ClCH2 and a molecular weight of 98.96 grams per mole. What is its molecular formula? When we're finding molecular formulas, what we need to know first off is the empirical formula. And they were lucky enough, or they were nice enough, and we were fortunate enough for them to give us our empirical formula. So the first thing we're going to do is find the mass of the empirical unit. So that is this. Okay, so chlorine has a mass of 35.5 grams. Carbon has a mass of 12.0 grams. Hydrogen has a mass of 1.0 gram. Now there are two of these, so that equals 2. There's just one of each of these here for the empirical formula. So that's 35.5 plus 12 plus 2. So that we add up to be 49.5 grams in a mole. So that's the molar mass of that empirical formula. So then what we do here, we figure out how many empirical units are in a molecular unit. So that's really just the ratio of what we're given. So we were given in a mass, we were given 98.96 grams per mole. 98.96 grams per mole for the molecular mass divided by 49.5 grams per mole for the formula or empirical formula mass. So EFM is empirical formula mass. We divide that out and we're going to get a ratio. And that comes out to be 2, basically 2, 1.999. So that is the ratio of molecular mass to the empirical formula mass. And that goes to the next step. So now we're going to write the molecular formula using the ratio from number 2. So that means we take this 2 that we found, and we have the original formula, ClCH2, and we're just going to multiply it by this number. So it's going to be Cl2C2H4 and H4. So that is the molecular formula. That's what the actual formula is. In review, we found our mass of the empirical formula. And once we had the empirical formula's mass, we had a ratio. And from that ratio, we multiplied it by the existing empirical formula to get our molecular formula. Okay, now this is a more difficult and challenging problem. But if we basically follow the same steps that we've learned so far, it shouldn't be so difficult. It just might be a little long. So if you have a compound that is 75.46% carbon, 4.43% hydrogen, and 20.10% oxygen by mass, it has a molecular weight of 318.31 grams per mole. So that's the molecular mass, not the empirical formula mass. What is the molecular formula for this compound? So we need to do really the same thing. We have to find the empirical formula first. Okay, so now to do that, we first change percentages to grams. So for carbon, we have 75.46 grams now. For hydrogen, we have 4.43 grams. And for oxygen, we have 20.10 grams. So now we're going to convert these to moles, the grams to moles. How many moles? So for carbon, we have 75.46 grams of carbon. That's we multiply that. 1 mole is 12 grams of carbon. That equals 6.29 moles of carbon. For hydrogen, we have 4.43 grams of hydrogen. We multiply that by 1 mole of hydrogen per 1.0 grams of hydrogen. That equals 4.43 grams of hydrogen. Now for oxygen, we have 20.10 gram of oxygen, and we multiply that for 1 mole of oxygen multiplied by or divided by 16.0 grams of oxygen. That equals, all right, so now we have 1.26 moles of oxygen. Now what we have to do is find the ratio of moles of each element. So remember, we're going to have to divide each of these moles by the smallest mole to get a whole number ratio. So let's, we know we'll take 1.26 moles. So for oxygen, that's the smallest, 1.26 moles of oxygen. We divide it by 1.26. That, of course, equals 1 mole of oxygen. Hydrogen, we'll just go backwards. 4.3 divided by 1.26. And we get 3.5 mole of hydrogen. Now hold on a minute there. It's we can't use that 3.5. I'll show you what we can do, and we don't round up with that. We have to get a whole number. And then we have carbon, and we get 4.99. Here we can round up. Now we can't round up the 3.5 because it's right there smack in the middle. So let's just write out what we had. We had C5H3.5 and O1, but we can't use that 3.5 and we can't just round up. So what we do is we multiply it by 2 to get rid of that 3.5. So we multiply everything by 2. So we get C10H7 and O2. Now this is the empirical formula, C10H7O2. And we're not done yet. We just figured out the empirical formula, but now we have to continue figuring out the molecular formula. So now we find the mass of the empirical unit, or the empirical formula's mass. And this is not, see, all these steps aren't very difficult. It's just kind of remembering how to do them all, or remembering to do them all. So we have to find the mass of this empirical formula that we just found. So we have 10 carbons. So for carbon, we have 10. We multiply that by 12.01. That's the mass of carbon, remember. We add that to 7 hydrogens, which has a mass of 1.0. And we add it to 2 oxygens, which has a mass of 16. We multiply that out, and we get 159.1 grams. That's the molar mass, so that's per mole. 159.1 grams per mole. That's what this weighs. Okay, so now we go back to what we did at the previous example. We figure out how many empirical units are in that molecular unit. So this is the empirical formula. So it's that ratio again. We had 318.31 grams per mole given to us in the beginning. Now let's take that empirical formula mass of 159.1 gram per mole that we just calculated, and we will get a ratio of 2. So then, remember what we do with that ratio, we just multiply it by our empirical formula. We have that original formula, the empirical formula, C10H7O2. Then we multiply it by the ratio we just found, C7H10O2. We multiply that by 2, so we get C14H20 and O4. That is our final molecular formula.